All right, so let's start talking about the membrane potential. And the first thing to chat about is what is the membrane potentials. It's a difference in ion concentrations on two sides of the membrane. You can see the concentration of sodium is higher on the outside, while the concentration of potassium is higher on the inside. And these ions being separated by the membrane because they are charged hydrophilic particles that cannot cross the membrane directly. So in order to cross the membrane, these ions would need some kind of a channel protein. Okay, so you see here sodium and potassium channels, and you see here sodium channel as well. So these hydrophilic ions, hydrophilic charged particles, can diffuse through the channels, essentially moving from the area with a high concentration to the area with the low concentration. For instance, in this image, you can see sodium diffusing from the area with its high concentration towards the area with its low concentration. You can also see in these images that the channels can be gated. You see the gate here and the gate here and gating here. The idea of gating is that the channel can be opened or closed, so opened or closed by some kind of a stimulus. If the stimulus is a chemical, here you can see acetylcholine chemical, we call such channels ligand gated. So essentially this is a typical ligand gated channel. If the channels are opened and closed in response to changing membrane potential, so you see opens at -70, closes at -70. So at certain number of membrane potential, certain value of membrane potential, the channel is getting opened or closed. We call these channels voltage gated, meaning that they respond to voltage changes in the membrane potential. And then not on any illustration, but there are channels that mechanically regulated. They respond to basically membrane distortions, mechanical stimulus, some kind of a pressure, for instance, or vibration. Okay? So if you would measure a membrane potential, and you can do it in the neuron, it's going to have negative value, -70 millivolts. You can see here that the charge on the inside of the membrane is negative, okay, while the charge outside membrane is mostly positive. So why is that important? It turns out that the signal in the neuron is transmitted in the form of an electric potential. So that change of the electrical potential of the neuron from -70 to +30 millivolts is called an action potential. Here you can see the steps of the formation of the action potential. So this is the resting state. You can see that sodium channel is opened, potassium channel is closed, and sodium starts to diffuse into the cell. Okay, here, look at this. Sorry, on this illustration, sodium channel is closed as well. Here, on this little picture, you can see that sodium channel let me erase some of that stuff. You see here, sodium channel opens and sodium starts to diffuse into the cell, bringing positive charges into the cell. This influx of positive charges means that the membrane potential of the cell for a short period of time becomes more and more positive. We call this process depolarization. When membrane potential due to the sodium influx reaches the value of 30 millivolts, sodium channel closes. You can see the closing here. Potassium channel opens, and potassium starts to diffuse out of the cell because the concentration of potassium inside is higher than the outside. The ion goes from the higher to lower, like the ball will go from higher to lower. And that diffusion of potassium brings the value of the membrane potential back down to negative 70 millivolts. Okay, then potassium channel closes, sodium channel is closed, so that's again a resting state, resting potential. So essentially this peak here, this peak change in the membrane potential of the neuron is called an action potential. The first phase here, when membrane potential becomes more and more positive, is called depolarization. This step right here, when it goes back, becoming more and more negative and reaching a resting state, we call it a repolarization, okay? And this is essentially a process of generating an action potential. Now, what's interesting, action potential always have the same value, okay? So what does that mean? It means that when this uptick of the potential happens, it will always go to plus 30. Always, no exceptions. It either can go to plus 30 or not happening at all. So every electrical impulse that goes through the neuron has the same electrical value, plus 30 millivolts. Okay? Cannot be plus 20, cannot be plus 10, it's plus 30 or nothing. This is often called all or none principle. Now, there is a term called graded potential, and we need to identify the difference between the graded potential and the action potential. So graded potential may actually assume different values. Here, you can see that the influx of the positively charged ions makes the membrane potential slightly more positive. Okay, cell becomes to be excited. That's actually excitation. But you see, it can be a little bit more, maybe slightly more, maybe slightly more like this. Okay, so those are graded potential that they call graded because they can be more negative, more positive. Okay, so in the neuron, those membrane potentials are called excitatory postsynaptic potentials. We didn't talk about synapse yet. We will talk about it pretty soon. Basically, excitatory postsynaptic potential shown here is the slight depolarization of the neuron. Depolarization, as we mentioned already, is the term for the neuron becoming slightly more positive. That brings cell closer to the threshold of forming a true action potential. So the more positive ions flow into the cell, the more depolarized it is, the more excited it is, the more likely cell is to fire, cell is to transmit the nerve signal. Case of inhibitory postsynaptic potentials, either influx of negative charge or efflux of positively charged ions going out of the neuron leads to membrane potential being more and more negative. That takes cell farther from the threshold of firing, making cell inhibited. Okay, so you need a bigger stimulus to initiate the action potential. I hope that makes sense. And this process, when cell becomes more negative, is called hyperpolarization. So again, cell becomes depolarized when positively charged ions flow into the cell, hyperpolarized when negatively charged ions flow into the cell, or positively charged ions leave it, okay, get out of the cell. In either case, depolarization is the change of the membrane potential towards being more positive, while hyperpolarization is the change of the membrane potential, which brings makes membrane potential more negative. Okay, so depolarizing stimulus is excitatory stimulus, while hyperpolarizing stimulus is inhibitory. Now we're gonna stop at this point, and we're gonna do another video on the synapses separately.